Okay, Unit 5 review. So, parts of a polynomial. So, first off, polynomial is what we're talking about is something like this, right? So, let's say we had 2x squared plus 4x minus 3, okay? So now we can talk about the different parts of this polynomial because there's a few names going that we have to remember here, right? So, first off, the biggest exponent, right? So it doesn't have to be at the beginning, right? Because I'll show you in a minute how we can rearrange this thing. But the biggest exponent, do you remember how that was called? The degree? Degree of a polynomial, right? So there'll be questions like that, right? Where they ask you what the degree of the polynomial is. You have to be able to know that one. It might also refer to, well, let's say for this example, if I asked how many terms are there in this? So terms, right? So remember, terms are things that are separated by an addition or a subtraction sign. So that's going to be, so this would be a term, and this would be a term, and this would be a term. So those are all, so you'd have 3 terms in that case, right? Those are my terms. Okay, next one, we've got our number out front. So our number out front, right, is a coefficient. Okay, so coefficient. So that's our coefficient, but that's also a coefficient, right? So the 4 would also be a coefficient, and so would the 2. And the coefficient is the number that's in front of your variable. So in this case, our variable is x, right? So our coefficient would be the number out front. Now this one, the 2, since that's with our highest exponent, with the degree 2 in this case, then actually you could even call that the leading coefficient. So leading coefficient. And then 4 would just be the coefficient. Okay, and then our number on the end, if we have one, right? Like you wouldn't have to have one with a polynomial. Our number on the end is going to be our constant term. Oh, my pen's a little off. Constant term. Okay. And I think, for the most part, that's pretty good. There's a few other things like, we could talk about, monomials. So a monomial would be something with, only one term. A binomial would be something with 2 terms. So maybe that's, something like 2x squared plus 4, right? 2 terms. That's a binomial, like a bicycle. Or a trinomial, right? So that's the one we have up here. So there's 3, so that'd be a trinomial. And then after trinomial, yeah, we don't usually get too much into it. It's really those 3. After that, it's just like it's a different type of polynomial, I guess. Okay, so that's it for for the parts mostly. Now, equivalent polynomials. So I'm just going to give an example here. So let's say one like this. Let's say if we had 2x squared minus 5x plus 7. Okay. So remember how we can just like move these terms around like they're little puzzle pieces, right? You can move them around however you like. I could rewrite that thing. It'd be exactly the same if I had it like this. Negative 5x plus 7 plus 2x squared. You see how all the terms are exactly the same, right? So this is like positive 7, negative 5x, negative 5x. There's no positive out front, but there really is, right? Like even if there's nothing written there. But you've got positive 2x squared and positive 2x squared, right? So you can move those pieces around whatever you like. So those are considered equivalent expressions. Okay, so another one, let's say we had something like this. So let's say we had 2x squared. I'll just write the same one. So minus 5x plus 7. And what about this? What if we had it written like 2x squared minus 3x minus 2x plus 7? Well, those are actually equivalent too. And we'll get, maybe I'm jumping ahead of myself here, but we'll get to this with the like terms part of it, where that part, right? Negative 3x minus 2x, I can actually collect those like terms, right? Because, well, they're just x. I'll get to that in a second though. But anyway, that'd be the same thing as 2x. And then I could actually just go negative 3 minus 2 is negative 5x plus 7. So those would also be considered equivalent polynomials. All right, so next one. collecting like terms. So first off, what is a like term? So a like term would be things that are alike, right? And by alike, here's what we mean. So let's say we had 3x squared, and then we also had, let's say, 2x squared. Those things are considered like terms because they have the same variable and the same degree on the variable, right? So those would be like terms. If I had something like, 2x and then minus 4x, those are like terms. And then it would also be true if you just had like 4 minus 2, even though there's no variable, those are still like terms. They're the ones without a variable on them. So they're like terms, right? So those are all examples of like terms. Another one, maybe we had this. Maybe we had 3x squared plus, I don't know, 4 over 3x squared. Those are still like terms, right? Those are still like. They've still just got the x squared and the x squared. But now I would just have to actually add. I'm getting ahead of myself again. We're going to talk about that down here, but then I'd have to deal with the fractions out, or the numbers out front, the coefficients. Be careful, because if we had one like this, let's say we had 2x squared and let's say 3 over x squared. Those aren't like terms, right? And actually, yeah, that's not going to work out for us. So it has to be up in the numerator like the other one was, okay? All right, so those are like terms. And then I had like collecting like terms, but really that is, when we say collecting like terms, we're really talking about adding and subtracting polynomials. So let's just jump right into it and do that. So let's say we wanted to add the polynomial. I really like 2x squared apparently. 2x squared minus 4x plus 2. And I want to add that to 3x squared minus 5x minus 7. Okay, so adding these guys together, adding's really the easy one because we can just kind of ignore these brackets, right? These brackets I have here, I set those up to begin with just to kind of say, okay, well, I'm adding this one and this thing in brackets. But in the end here, all I'm going to do is I'm going to collect my like terms. So I did this different ways in class, right? Where I did put like different shapes around them. So you could write it all again without the brackets. I'm just going to ignore them so I don't have to write it all again. But I'm going to put a circle around all of my x squared terms. Okay. And let's add those right now, right? We can do piece by piece here. So 2x squared plus 3x squared. So the like term stays the same, right? Like the x squared part of it stays the same. So I just have to go 2 plus 3. This is just 5x squared. So there you go. There's my first piece of the piece there. Now let's do our x terms. So here, I'll put a box. You guys might not have colors. So a box. Okay. And make sure you get the negative in with the box because that's going to matter, right? So it's going to be negative 4x minus 5. So if you're at negative 4 and you go 5 to the left, right? You're going like more to the left. It's like you're adding these things, but you're going more negative. So that's going to be negative or minus 9x. Okay. Then the last one here, we're going to have, I'll put a triangle maybe around just our numbers on the end there. So we've got 2 minus 7. So if you're at 2 and you take away 7, you're going to be at negative 5 or minus 5. So there you go. There, we added polynomials. So there's going to be one more here, but we're going to do subtracting. So let's say we had this. Let's say we had 2x squared minus 5x plus 4. So that's our first polynomial, and we're going to subtract 5x minus 2x, 5x squared minus 2x plus 3. Okay, so what we want to do here now, this changes things up a little bit. We have to deal with this negative, right? So whenever you subtract a polynomial, whenever we subtract this, right, like this whole thing, what's really going to happen here is that we're subtracting not only, just the negative 5, you're really subtracting each one of these things individually, right? You're going like minus 5x squared minus negative 2x minus 3, right? All of these things are like the opposite, right? So if you remember, what we do when we're subtracting is we really just like take away the brackets, just get rid of the brackets, and then we change the sign on all of these. So if this was positive 5 up front, now it's negative. If this is negative 2, now it's positive. This is going to be negative 3, right? So we just switch all the signs. So this would be 2x squared minus 5x plus 4, and then so that all stayed the same, right? The first one stays the same. And then the second one, this will become now minus 5x, and then plus 2x, and then minus 3, right? Just the opposite of all those signs. And then we're right back to where we were for the other one, right? So now we're just collecting like terms. So let's do, I'll put a circle around my x squared. Oh, sorry, forgot the squared on that one. Squared. Okay, so 2 minus 5 is negative 3 x squared. And then negative 5 plus 2 is going to be, again, negative 3x. And then 4 minus 3 is going to be positive 1. Okay, so there you go. We subtracted some polynomials there. All right, next, multiplying and dividing polynomials. Okay, so multiplying and dividing. So let's do multiplying first. Let's say we had one like this. Let's say we had 2 times x squared plus 4x. So technically this is multiplying polynomials because 2 actually is, just 2 by itself is technically a polynomial. So it's like 2 times that. So monomial times a binomial. All right, so maybe you guys remember this, maybe you don't. What we're gonna have to do here is, this statement really means I've got to go 2 times that first term, and then I've got to go 2 times that second term. All right, so I actually got 2 things. I call that rainbow, right? Like when we were doing it. So I just really got 2 things to do here. So let's do the first one. 2 times x squared. Now, there's not much we can do because 2 and the variable, those are like 2 different things, right? So all we can really do there is just call it 2x squared. And that's it. Okay, for the next part of my rainbow there, we're gonna have 2 times 4x. So all I can do is multiply the number by the coefficient. So 2 times 4 is 8. And then the x doesn't really change. So that's going to be, and it's positive, right? So positive 8x. And there you go. We multiply the polynomial. So now let's make it a little bit tougher. I'm going to throw in like another number with, or like a variable out front as well. So let's say we had, or let's make it really tough, negative 3x squared times 2x plus 3x squared. All right, so we've got a monomial times by a binomial. So again, we got to do the rainbow, right? So it's going to be multiplied by both of those. So let's do them one at a time. So we got negative 3x squared times 2x. Just ignore the x's for a second. We've really got negative 3 times 2 is the first part of it. So that's negative 6. So negative 6. And then we also have to account for the variables, right? So x squared times x. Let's review this. So x squared times x is really like x squared times x to the power of 1. What do you do with those exponents, right? So remember what we do? We add those exponents. So that'd be the same thing as x to the power of 3. So same thing here. This will be x to the power of 3. Okay. Let's okay. So next part. So next part of the rainbow here, we've got negative 3 times 3 is negative 9. So it's like minus 9. And then x squared times x squared. So again, we're going to just add the exponents. That's the same thing as x to the 4. So that's right. Like that's our answer. Technically, we should put it in descending power of x though. Like we want our biggest exponent out front. So I'm just gonna flip this around. I'm just gonna call this instead negative 9x to the 4 and then minus 6x to the 3. All right, that's the same thing. I just moved it around. Okay. All right, so that's multiplying. All right, so let's do another one now with division. So let's do one like this. Let's say we had negative 8, can't write, 8 x squared minus 4x to the 6 plus 2. And we go divided by, let's say we divide it by negative 2. Actually, here, I'm going to make this an x up there. Negative 2x. All right, so just like the last one, right? Do you remember how we did like a rainbow for both of those? We had to like apply the 2 to both terms. We really got to do the same thing with division, right? Where I technically have to go like this term here divided by negative 2x. And then this term here divided by negative 2x. And then this term here divided by negative 2x, right? They just, each one of them is going to have to be divided by negative 2x, right? The same way that the rainbow happened on the multiplying. So let's do that again. So piece by piece. So negative 8x squared divided by negative 2x. All right, so let's even just write that over here for a second. Negative 8x squared divided by negative 2x. So what would that be? So up top here, we've got negative 8 divided by negative 2. So that's coming out positive no matter what, right? So I got a positive number. 8 divided by 2 is 4. And then x squared divided by x. So in the same way on these ones, when we multiply, do you remember, like I just said, we added the exponents? When we divide, we subtract the exponents, right? So this is going to be 4x, right? Because it's x squared minus x to the, there's technically a 1 sitting there. So like 2 minus 1 is 1 still. Okay, so that's our first part. So we've got 4x. That's what that first one's going to be. The second one, I've got, again, negative divided by a negative, so it's going to be positive. So positive. 4 divided by 2 is 2. And then for my exponents, right, this is like a 1. So 6 minus 1, that's going to be x to the power of 5. And then the last one here, 2 divided by negative 2. So positive divided by a negative, that's coming out negative. So that's like negative 1, if you like, right? And then what we got here? We got 1 minus 1, right? That's like 0. But remember, x to the power of 0 is actually 1, which is kind of a weird one. Weird one. So they cancel, right? Like x to the power is, you end up with a 1. So you could say times 1 if you like, but it's probably easier just to think about these as canceling at this point, right? So so this is it. You just got minus 1 left over there. And then here, I'll move this around so that I've got my leading coefficient out front. So that would be the same as 2x to the 5 plus 4x minus 1. And there you go. That'd be it. All right, so that's pretty much the whole unit in a nutshell.